Greetings, detectives. It's Mrs. McKay, and we're getting ready to start Case 3, Sequence Scenarios. And it's all about sequences. And sequences are kind of cool. And we're going to start with something simple, which is arithmetic sequences. And we've actually done some of this already. You just didn't realize it. And you might start noticing what I mean as we move through this case. But let's go ahead and get started by just writing our learning target, and that is I can identify an arithmetic sequence. So write the word sequence here. And its constant difference. So write the word difference here. Using tables and graphs. So that's our learning target. I can identify an arithmetic sequence and its constant difference using tables and graphs. Now, before we go any further, I want to go over a little bit of vocabulary with you. So look over here where it says sequence. What is a sequence? Well, a sequence is just a series of numbers. A series of numbers. So go ahead and write that. But those series of numbers usually have a pattern. So with some kind of pattern, all right? In this case, we're only going to be looking at two different types of sequences, arithmetic sequences and geometric sequences. There are many other types, but we're just going to focus on those two, arithmetic and geometric. And today, just arithmetic. Now, the other thing that the other word that you're going to need to know is discrete and continuous. Discrete and continuous. Those two words mean the opposites. So a discrete sequence has individual points, and you're going to see this when we graph things. So for example, if we were going to graph a sequence, we might graph the points like this. That is a discrete sequence. It means that each point stands alone and it's not connected by a line. And you'll understand more of that as we go through this. But partly, usually in a sequence, we have information, and it's a series of information. So it's a series of numbers, and maybe it's related to counting time or counting days or something like that. And it's on day 1, this happens. On day 2, that happens. And there's no any in-between days. It's day 1, day 2. So there's nothing that's happening in between. There's no fractions. So discrete sequences or discrete data are just the dots on the line. They look like, or the dots, the points on the graph, they look like a line, but we don't connect them. Whereas continuous data might have points on the line that are connected because everything on the line would be appropriate data. So you'll see what I mean as we move on, but those are just two words, discrete and continuous. Okay, so discrete are the individual points, continuous means the points are connected and all of the line is part of the data or part of the information. And then the last thing is difference. And when we talk about difference normally, we normally mean, oh, that's the answer to a subtraction problem. And that's true. But in this situation, the difference is going to be whatever we do to one number to get to the next number. All right? Whatever we do to one number to get to the next number. So go ahead and write whatever we do to one number. I'm going to just use the hashtag. That also means number, in case you didn't know. Whatever we do to one number to get, let's just say, the next number. So go ahead and make sure that's written. All right? Now, let's go ahead and try some of this out. Let's look at these sequences and see if we can see a pattern. For this one, I have 1, 5, 9, 13. Do you know what the pattern is? Do you see how I could get to the next number? Why don't you take a guess? So I think you may have noticed that from here to here, from 1 to 5, we added 4, right? And then from 5 to 9, we added 4. And then from 9 to 13, we added 4. So the next number would be 4 more, which would make it be 17. Okay? Go ahead and do the next one. Do you see the pattern? 8, 6, 4, 2. Did you notice that from 8 to 6, we subtracted 2? And from 6 to 4, we subtracted 2. And from 4 to 2, we subtracted 2. So what would the next term be? We subtract 2 and we get 0. Go ahead and do this next one. -5, -8, -11, -14, and see if you can find the pattern. Did you see that it is subtracting 3? -5 to -8 is subtracting 3. -8 to -11 is subtracting 3. And -11 to -14 is subtracting 3. So that means that the next term would be subtract 3 again, and we'd get -17. Now, let's look at this last one. Did you notice what we did, what the pattern was? We added 10. Plus 10, plus 10. So one thing that I hope that you noticed in each one of these, whether it was 1, 5, 9, 13 or 20, 30, 40, 50, each time we added or subtracted the same number. We added or subtracted the same number. That number is called the constant difference. So I'm going to write constant difference. We say it's the constant difference. Sometimes you might hear it as the common difference, but either way, we're going to say it's the constant difference, and that's because it stays the same. It's constant, and we either add or we subtract. We do not multiply or divide, we only add or subtract. So it's the constant difference. So what was the constant difference in this first one? It was plus 4. And the constant difference in this one was -2. I'm going to make this a little bit bigger. Plus 4, minus 2. Here it was plus 3. And right here it was plus 10. The constant difference. Now I'm going to have you do a little bit of practice to see if you can decide whether something is an arithmetic sequence. So these are all called arithmetic sequences. And the key is that it's a series of numbers, and it has a constant difference. We do the same thing to each term to get to the next thing, and we either add or we subtract. That constant difference is either an add or subtract. So you try some problems now. All right, hopefully you did okay. Now let's go ahead and just see how we can use arithmetic sequences and how they can be represented. Take a look at this little problem here underneath tables, graphs, and lines, finding the constant difference. It says, Scott has decided to add push-ups to his daily exercise routine. He is keeping track of the number of push-ups he completes each day in the bar graph below. So here's the bar graph right here. Okay? With one day showing he completed 3 push-ups. So you can see that on the first day he did 1, 2, 3 push-ups. And then on the next day he did 1, 2, 3, 4, 5. So he's adding the number of push-ups that he does each day. On the third day he did 1, 2, 3, 4, 5, 6, 7. 7 push-ups. And on the fourth day, he did 1, 2, 3, 4, 5, 6, 7, 8, 9. So I hope that you notice that what he's doing is on the first day, he did 3 push-ups. And the next day, he did 3 plus 2 more. See that? And then on the third day, he did the number that he did on day 2, which was 5, and he added 2 more. And then on the fourth day, he did this amount that he did on the third day, which was 7, and he added 2 more. So what is our constant difference in this scenario? Well, it's plus 2. Our constant difference is plus 2. So that's a picture of this sequence. Now let's write it in a little table over here. Let's write it in a table. On day 1, he did 1, 2, 3 push-ups. On day 2, he did 3 plus 2 more is 5 push-ups. On day 3, he did 3 more plus 2 more 5 push-ups plus 2 more, which is 7. And on day 4, he did 9. How many do you think he did on 5 and 6? Go ahead and fill those in. Did you put 7? Whoops, not 7. Silly me. 11 and 13. You should have, because each time we added 2. Okay? So this is just another way to look at a sequence in sort of a table that goes across. Days go across the top, 1, 2, 3, 4, 5, 6. Push-ups, 3, 5, 7, 9, 11, 13. Another way to represent this information, this data, is to do a little T-chart. So down here I have a little T-chart, and I'm going to say X and Y, where X is the number of days and Y is the push-ups. All right? So when X is 1, Y is 3. When X is 2, goodness gracious. When X is 2, Y is 5. That's right, 3, 4, 5, and 6. And then let's do 3, 7, 9, 11, 13. Okay? So this is a little T-chart. We call it a T-chart because it makes a T, and it's a way that we can plug in or plot points. And the last thing that we'll do to represent this sequence is we'll go ahead and graph these points. So when X, this is X, and this is Y. When X is 1, Y is 3. Let me try to change this color. When X is 2, Y is 5. When x is 3, y is 7. When x is 4, y is 9. When x is 5, y is 11, and I'm running out of graph. So that's good enough. You can kind of see that I have at least the first 5 days are marked on this graph. This is a discrete graph, not a continuous. I'm not going to connect my line. I'm not going to connect my points and make a line because he didn't do push-ups in half a day. He did on day 1, he did 3 push-ups. On day 2, so here's 1, 2, 3. You get it, right? On day 2, he did 5 push-ups. There wasn't like, halfway in the day he did 4 push-ups. No, he did 3 on one day and 5 on the next day. So these are discrete points. We're not going to include all of the information in between these points because there isn't any information that we would record. Sometimes, though, we might record, we might connect the line, like maybe we're measuring temperature and the temperature fluctuates and changes. We might then connect the dots, and then we would have a continuous graph, but in this one we just have a discrete graph. So those are all of the different ways to show arithmetic sequences, and the cool thing about it is that they all have this common difference. So here on this one, you can see where we added 2. We can look at these numbers and see that we added 2 to get to the next one, right? And the other thing that we can look at, the same here, from here to here, we added 2. This one and this one are very similar. They're just one's horizontal and one's vertical. But the one thing that I want you to also notice about this graph is that if there was this imaginary line, because it is sort of forming an imaginary line, there's a slope. And what's the slope of that line? Well, that slope is up 2 over 1. So the slope of this line is 2, which is the common difference. So do you see how all of those things are connected and related? It's kind of cool the way math does that. All right. So that is a problem that has a arithmetic sequence, and we could actually predict what each day is. We could predict the 100th day. We could predict it in a number of different ways, but you can see how an arithmetic sequence will allow us to kind of make predictions. And we'll talk about that more, the 2 different ways that we can predict it in our next lesson. So now I just want us to have a little bit of practice in finding the next 3 terms in an arithmetic sequence. So over on the column, you've got 5, 2, -1, -4. And I'd like you to go ahead and see if you can figure out what the common difference is and then write what the next 3 terms are. So go ahead and do that. And hopefully what you saw was that you saw that from 5 to 2, you subtracted 3. And from 2 to -1, you subtracted 3. And from -1 to -4, you subtracted 3, so that you put your next 3 terms were -7, -10, and -13. Try the next one. On this one, you should have seen that from -8 to -2, you actually added 6. And from -2 to 4, you added 6. And from 4 to 10, you added 6. So your next 3 terms would have been 16, 22, 28. And go ahead and do the last one. this one was a little bit trickier. But if you looked really carefully, you would have seen from 1.3 to 1.7, you added 0.4. So then from 1.7 to 2.1, you added, let's put a little plus sign there, 0.4. And from 2.1 to 2.5, we added 0.4. So that means we need to add 0.4 to 2.5, and we get 2.9. And when we add 0.4 to 2.9, we get 3.3. And when we add 0.4 to 3.3, we get 3.7. So there we have it, arithmetic sequences. So there's a few things to remember about that. Remember that an arithmetic sequence is a series of numbers with a constant difference between each term. And that constant difference is adding or subtracting. So you might even want to write here, add or subtract. Okay? And then also that a sequence can be represented by pictures, tables, graphs, and even equations. We just didn't talk about that yet. We're going to talk about that in Clue 2. Go ahead and think about a key idea that is important for you to remember so that you can really understand arithmetic sequences. Write that key idea down at the bottom, and I'll see you in class.